This problem concerns a fairly complicated expression for finding the variance in terms of a conditional variance. We remember that the expected value of x can be written as the expected value of x, the expected value of x given y. And this is a way of being able to do the same thing with a variance. Okay, so let's see if we can simplify what the variance of x given y is. The variance of x given y is equal to the expected value of x minus the mean, the expected value of x given y, squared given y. And this kind of parallels the ordinary definition of variance that we had way back when, the expected value of x minus the mean squared. So that was the definition of variance way back when, and we see that we have the basic parts here, we have the x here, and also the expected value of x, except it is a conditional expectation instead of the regular expectation. Okay, so let's simplify this and see what we get. So squaring out, we get the expected value of x squared minus 2 times x times the expected value of x given y, plus the expected value of x given y squared given y. Okay, so let's split this up and try to divide and conquer here. Expected value of x squared given y minus 2 times the expected value of x times the expected value of x given y. And then we have plus the expected value of x given y squared given y. Okay, so how are we going to approach this now? First off, we note, well, the first term is going to carry along for the ride, expected value of x squared given y. Next, I note that this right here, the expected value of x given y, is basically a constant with respect to y. In other words, this is a function of the random variable y. So giving the value of y gives me no extra information, and so this constant here can be pulled outside of the expectation. And it's a constant because this is a conditional expectation. So pulling that out, then what's left is going to be the expected value of this x given this y. Okay, now over here, once again, this is a function of the random variable y. And so this right here can simply be pulled outside of the expectation, the expected value of x given y squared. And all that's left is expected value of 1 given y, which is going to be 1. So that's equal to the expected value of x squared given y minus, here I have 2 times expected value of x given y squared plus the expected value of x given y squared. So that's equal to the expected value of x squared given y minus the expected value of x given y whole thing squared. So that is the variance of x given y. Okay, now the question asks us to show that the variance of x is equal to the expected value of the thing that we just got plus this new thing. Okay, so to get started on this, let's figure out the expected value of the variance of x given y. So that'll be the expected value of the expected value of x squared given y minus the expected value of the expected value of x given y squared. Well, there's no shortcut to this. That doesn't get any simpler, so that just carries along for the ride. This part, however, does become simpler. It's the expected value of something, and the expectation of this conditional expectation is simply the expectation. So that's the expected value of the variance of x given y. Next, let's figure out the second part here, variance of expected value of x given y. So reversing, variance of expected value of x given y. By our rules, this is the expected value of the inside squared minus the expected value of the thing squared. So the variance of something is the expected value of the something squared minus the expected value of the something whole thing squared. Now this first part doesn't get any simpler. Just leave it alone. The second part, I've got the expected value of a conditional expectation, and the expectation of the conditional expectation is simply the expectation. And then I have this outside squaring. So what happens if you add this up? If you add up these two things, so I get this term minus this term. Then I have plus this term which looks awful familiar, minus this term. And so these cancel, and I'm left with the expected value of x squared minus the expected value of x whole thing squared, which is our good friend, the variance of x. And so that is the proof that the expectation of the conditional variance plus the variance of the conditional expectation is equal to the variance.